Okay, welcome guys. Welcome to my channel. So in this video, I'm going to discuss about computer network models. As in the previous video, I discussed about the communication, different type of communication, uh, like simple duplex, half duplex, full duplex modes, and here the computer network models where so communication subsystem is a complex piece of hardware and software. Early attempts for implementing the software for which subsystems were based on single complex and unstructured program with many interacting components. The resultant software was very difficult to test and modify. So to overcome such problems, the ISO has developed a layered approach. The network concept is divided into several layers, and each layer is assigned to a particular task. So therefore we can say the networking task depends upon the layers. The layered architecture, where the main aim of this layered architecture is to divide design into the small pieces. So each lower layer that adds its services to the higher layer to provide a full set of services to manage the communication and run the applications. Okay, so each layer, the lower level adds the services to its upper layer or higher layers to provide a full set of services to manage the communication and run the applications. It provides a modularity and a clear interfaces, that is provide the interaction between the subsystems. It ensures the independence between layers by providing the services from lower to higher layer without defining how the services are implemented. Therefore, any modification in the layer will not affect to the other layers. The number of layers, functions, contents of each layer will vary from network to network. So the purpose of each layer is to provide the services from lower level to higher level and hiding the details from layers of how the services are implemented. Okay, so the basic elements of the layered architecture are the services, protocols, and interfaces. Services means set of actions that a layer provides to the higher layer. Okay, set of actions that a layer provides to the higher layer, and protocol a set of rules that a layer uses to exchange the information with the peer entity. Okay, so the protocol means the set of rules that the layer uses to exchange the information with a peer entity, and these rules mainly concerned about both content and order of the messages used. Interface, it is the way through which the message is transferred from one layer to another layer. Okay, the interface, so here the message transferred from one layer to another layer. Let us take an example of 5-layered architecture. So here this 5-layered architecture, layer 1 is a lower layer and upper layer. So services providing from lower layer to upper layer. So these are the 5 layers. In case of this layered architecture, no data is transferred from layer n of the one machine to layer n of another machine. So instead, each layer passes the data it passes the data to the layer immediately just below it until the lowest layer is reached. So below here is this layer 1 is a physical medium through which the actual communication takes place. In a layered architecture, the unmanageable tasks are divided into several small and manageable tasks. And the data is passed from upper layer to lower layer through a interface. Okay, so that is about the set of layers and protocol. It is known as network architecture. So why do we require layered means So here the divide and conquer approach, dividing the large task into the small task, and modularity. Okay, so next we'll discuss the very important topic, that is OSI model, open system interconnection model. Okay, so this open system interconnection model is a reference model that describes how the information from software application, okay, so how the information from a software application in one computer moves through a physical medium to another software application in another computer. Here the data is transmitted through the physical medium. Okay, the data is transmission from one computer to the another computer. So OSI, open system interconnection, that consists of how many? 7 layers, and each layer that performs a particular network function. So OSI model was developed by the International Organization for Standard Organization, that is ISO, in 1984. Okay, the OSI model in 1984, and is now considered as architectural model for the intercomputer communication. Okay, so this is a standard architecture model that we consider for intercomputer communication, and OSI model that divides all tasks into the smaller and manageable task. How many OSI model? How many layers are there in the OSI model? That is 7 layers. 7 layers. So each layer is self-contained, so that a task assigned to each layer can be performed independently. So the characteristics of this open system interconnection model is here the characteristic: responsibility of the host and responsibility of the network. So these are the 7 layers: 1, 2, 3, 4, 5, 6, and 7. Physical layer, data link, network layer, transport layer, session layer, and presentation layer, and application layer. Okay, so this OSI model, it is divided into the 2 layers, upper layer and lower layer. So upper layer, that is transport layer, session, presentation, and application layer, and the lower layer is physical, data link, and network layer. Okay, the upper layer of OSI model is mainly deals with application related issues, and they are implemented only in the software. So application layer is closest to the end user, so both the end users and the application layer interact with the software applications. Okay, so the upper layer, transport layer, session layer, presentation layer, and application layer. So this upper layer of the OSI model that mainly deals with the application related issues. Okay, which one? Transport layer, session layer, then presentation layer, and application layer. So these 4 layers, upper layers, that mainly deals with the, okay, these application layers are closest to the end user, okay, and implemented only in the software, and this application layer is closest to the end user. So both the end users and application layer, they interact with the software applications, and upper layer refers to the layer just above the another layer, that is lower layer that contains the physical layer, data link layer, and network layer. Okay, physical, data link, network layer. So this is the lower layer. Okay, so the lower layer, the OSI model deals with the data transport issues, and the data link layer and physical layer are implemented in the hardware and software. So the physical layer is the lowest layer of the OSI model and is closest to the physical medium. So the physical layer is mainly responsible for placing the information on the physical medium. Okay, so the functions of OSI layers are here. These are the 7 layers: physical layer, data link layer, network, transport, session. Okay, then session and presentation and application layer. So these are the 7 layers of OSI. So let us discuss one by one what are these layers. So physical layer. Here it provides a physical medium through which bits are transmitted. Okay, in physical layer, bits are the data. Bits are transmitted. It provides a physical medium through which the bits are transmitted. Okay. Then data link layer. It is used for the error-free transfer of data frames. Okay, error-free. It is used for error-free transfer of data frames. Error-free transfer of data frames. So in the physical, it provides a physical medium through which the bits are transmitted. Data link layer, the data frames. And in the network layer, it is responsible for moving packets from source to destination. Network layer. And in the transport layer, it provides a reliable message delivery from process to process. Okay, so here error-free data frames, transfer of data frames, and network layer is moving the packets from source to destination. Okay, so in your mind should come physical layer means the bits are transmitted. Physical medium through which bits are transmitted. Here in the data link layer, the data frames are transmitted. Data frames from the source to destination. And in the network layer, it is responsible for moving the packets from source to destination. Okay, packets from source to destination. And in the transport layer, it provides a reliable message delivery from process to process. Okay, reliable message delivery from process to process. Next comes the session layer. So it is used to establish and manage sessions. Okay, it creates a session, it terminates the session. So it is used to establish, manage, and terminate the session. So that is in the session layer. And in presentation layer, it is responsible for translation. Okay, translation, compression, and encryption. The presentation layer, it is responsible for the translation, encryption, compression. Okay, the presentation layer, compression of the data, encryption. Okay, and application layer, last layer. This layer provides the services to the user. Okay, it provides the services to the user. Okay, so this is very important. You should know all the layers. Okay, you should know all the layers. So here let me add one. Okay, great. Here space is there. Okay, here I will write. So the first layer is a physical layer. Then the second layer is the data link layer. Okay, then third one is network layer. Then transport layer. Then session layer. Then after that presentation layer. presentation layer, then comes the application layer. Okay, so here the main thing is that in the physical layer the data transmission is in the physical medium in which the bits are transmitted. Okay, the data in terms of bits, the data link layer where the data frames are transmitted, data frame, and a network where packets are transmitted from source to destination packets. Okay, then in the transport layer, okay, where it is responsible for to see, this is the upper layer, this is the upper layer, and this is the lower layer. Okay, so to reliable message from process to process. Okay, so it means it ensures the reliable transfer of message, reliable transfer of message from source and destination. Then in the session layer, it like creates, manage, and terminate the sessions. Okay, it establish the it manage and terminate, it create a session, create a session, create, manage, and terminate. Okay, and at the presentation layer where okay, so here it presentation layer means let's for translation, encryption, and compression of the data, responsible for the translation, compression, and encryption, of the data. Then in the last, it provides the services to the end users. Okay, so physical layer where it medium in which the bits are transmitted. So the physical medium, the main functionality of the physical layer is to transmit the individual bits from one node to another node. Okay, it transmits the individual bits, from one node to another node. Okay, so here it is a physical layer. Okay, so the data transmission medium bit by bit. Okay, so here from data link layer to physical layer. Okay, so here we are transmitting to data link layer. So the main functionality of physical layer is to transmit the individual bits from one node to another node, and it is the lowest layer of the OSI model. It establishes, maintains, the deactivate the physical connections. It specifies the mechanical, electrical, procedural, network interface specifications, and for physical layer functions are like line configuration, where it defines the way how two or more devices are connected physically. The data transmissions, it defines the transmission mode, whether it is simplex, half duplex, or the full duplex mode, the data transmission. Then topology defines the way how network devices are arranged. Topology means here how the network devices are arranged. Next, from data link layer, data frames, for error-free transfer of data frames. So this data link layer, it is responsible for transfer of the data, that is error-free data from one layer to another layer. Okay, so it defines the format of the data on the network. So here it is the the data frame from network layer to this physical layer, like with the data frames, and here it is bits, and from here to network layer. It mainly responsible for the unique identification of each device that resides on the local network. So it contains the two sub layers. Okay, that is logical link control layer and media access control layer. In the logical link control, it is responsible for transferring the packets to the network layer of the receiving that is receiving, and it identifies the address of the network layer protocol and with the from the header. Okay, so in logical link control, it identifies the address of the network from the header, and it also provides the flow control. And the data link control layer and logical link control layer and media access control layer. So it is the link between the logical link control layer and the network physical layer. Okay, media access control, the link between logical link control layer and network physical layer. It is used for describing the or transferring the packets over the net. Okay, so we'll discuss this one, data link layer form functions, where framing here the data link layer translates the physical raw bit stream into packets known as frames. Okay, physical raw bit stream into packets known as frames. The data link layer that adds the header and trailer to the frame. This is the header and this is the trailer that adds to the frame. The header, which is added to the frame, that contains the hardware destination and source address. Okay, so here the header what it contains, it is added to the frame that contains the hardware destination and source address. And physical addressing, flow control, access control, these are all different other components, the functions of data link layer. Error control, that is achieved by adding the calculated value of CRC, cyclic redundancy checksum, that is placed in the data link layer trail. Okay, so we'll discuss in the next video about the network layer and all other different OSI model layers.